Okay, whoopsie daisies. I told you that you could try these on your own, 7, 8, 9, 10, but actually they're new information. You may not be familiar with it, so you might need to follow along with me. Sorry about that. So we have now a little bit different where instead of having just theta right here when we're solving our problems, we have 2 theta or theta over 2 or 3 theta, etc., or theta over 3. So how does that impact our solutions or the amount of its solutions? So it says some trigonometric equations are in the form of multiple angles where this k is in front of the angle measure. So what do? So I'm going to show you. So pretend that maybe 2 theta is equal to a. So we have 2 sine of a equals to root 3. So we move the 2 over because we're trying to isolate the a. So sine of a equals root 3 over 2. Well, when will sine of a equal root 3 over 2? That's our y value, so that's when we have a pi over 3. So a is equal to pi over 3, but remember there's 2 times it's positive, so it's pi over 3 and 2 pi over 3. Okay, but really it's not a. Instead of a, we have 2 theta. The other thing we need to notice is that there is no domain restriction, so we have to do the general solution, right? So we have to make sure we do our general solution. So we have pi over 3, 2 pi over 3, and then we would add our 2 pi k, where k is an element of the integers. Now we know this isn't the right answer, or you should have a gut instinct that it's not, because it's not a, going back to that, sorry, it's now 2 theta. So you have 2 theta equals pi over 3 and 2 pi over 3, and then we have our general solution plus 2 pi k, where k is an element of the integers. Well, we want to isolate theta and make this theta by itself, so to get rid of this 2, we have to divide the left-hand side by 2. But if we divide the left-hand side by 2, we must divide the right-hand side by 2. Not only do you have to divide your solutions by 2, you have to also divide the period, or what you're adding on to it, by 2, because it's altering the whole entire thing, right? So we have now as our final solution, what color do I want? Sorry. Theta would equal pi over 6 and pi, or you could just do 2 pi over 6 if you didn't want to cancel those 2's, right? Pi over 6, 2 pi over 6, plus pi k, where k is an element of the integers. So that is your final answer. And that's it. So it's not difficult. It's just something maybe that you didn't know. So this 2, remember, what does that 2 mean? Well, if we're graphing it, that means between 0 and 2 pi, we have 2 cycles of the sine curve, right? So we're going to have more solutions where it equals positive root 3 over 2. We're going to have that happen 4 times, or it's going to, if we want to do it from here in the 1 cycle, then it's happening every pi k, and we can get those first 2 answers. So it horizontally shrunk it, made it repeat more often, which is why all of this information changed. Okay, let's try example 8. We first need to isolate cosine of theta. So cosine of theta over 2 equals negative root 2 over 2. When will cosine equal negative root 2 over 2? Well, that's when cosine is equal to pi over 4. So theta over 2 is equal to, well, we want it to be negative. So when is cosine negative? Well, it's negative in the second and third quadrants. So that is going to be 3 pi over 4 and 5 pi over 4, and then we would add our 2 pi k because we have our general solution. But this time, instead of dividing each side by 2, we need to multiply each side by 2. So our final solution for theta is 6 pi over 4 and 10 pi over 4 plus 4 pi k, where k is an element of the integers. Now, do you have to leave it at 6 pi over 4, 10 pi over 4? No, if you did the math in your head and you wanted to write 3 pi over 2 and 5 pi over 2, that is also fine. But you must have 4 pi k, and you must tell us and define what k is. Oops, so either of these answers are fine. right? We don't care if you simplify or not. In fact, I would discourage you from simplifying. I would just keep it like this in case you make that little error of how you simplified. Okay, now 9 and 10 are a little bit different. We are giving you a domain restriction, and then we're asking how many solutions you will have. So how many solutions are there to the equation sine of 3 theta equals 1/2 on the interval from 0 to 2 pi? So you have two ways you can approach this. You can approach it graphically, but if we ask you a question like this, you'll see them on previous quizzes. If you have any from last year, you look at them from last year. We ask you to show work. So you can't just put an answer down. You have to verify or justify your answer. So you're going to have to show some work. So you're either going to have to explain it using your words, or you're going to have to do it graphically, or you can also perhaps go about it algebraically. So first I'll show you graphically. I'm visual, I like the graph. So remember, what does this mean? This 3 right here means we're going to have 3 sine curves. 1, 2, 3, right? From 1 to -1, that doesn't really matter. So here's 1, there's 2, there's 3. Then you could just say to yourself, okay, when is sine going to equal 1/2? So I just draw a little line that looks like 1/2. So it's 1, 2, 3, 4, 5, 6. So there are 6 solutions from 0 to 2 pi based on this. So I know I'm going to have 6 answers there. So that's it. You could also say, yeah, I mean, that's what we're doing. There's 3 cycles, right? So that's how many cycles? 3 cycles. There's 2 solutions per cycle. So you could also write this out in sentence form. Therefore, there are 6 solutions. Or you could graph it. The other way you could do it is you could say, okay, typically we get theta, or we take this domain restriction. We say theta is cut between 0 and 2 pi. Now what are we doing to theta? We're multiplying it by 3. So we have to multiply each section by 3. So now 3 theta is caught between 0 and 6 pi. So if you do this, I'm not sure that it's less confusing this way, but if you do it this way, it's not really algebraic, not really proper words. It's just a different method of showing how many solutions you have. So think of the regular sine curve between 0 and 6 pi. So you would have one sine curve at 2 pi, so another sine curve at 4 pi, and another sine curve at 6 pi. There's 2 solutions for each one, so it's 2, 4, 6. So it's the same thing. So 2 solutions every 2 pi. There are 3 sets of 2 pi, therefore there are 3 sets of 2 solutions, there's 6 solutions. So I'm not sure if that helps or if you like the graphing, it's up to you. Why don't you try one or the other for exercise 10, see if you can figure out how many solutions there are, and then check your answer here momentarily. So for number 10, it might be easier to do this right-hand side type method. So if I go from negative pi, and my theta is caught between negative pi and 6 pi. So if I am going to divide everything by 3, so now I have negative pi over 3, and then my theta over 3, and now I have 2 pi. So I'm trying to get cosine equal to negative root 3 over 2. When you do this adjustment that I just did, you can now think of how many solutions there are in a traditional cosine curve between 0 and 2 pi. So between 0 and 2 pi, how many times will cosine equal negative root 3 over 2? Well, that will happen twice, right? So there's 2 solutions between 0 and 2 pi. But I'm not going from 0 to 2 pi, I'm going from negative pi over 3 to 2 pi. So all you have to do is think back, okay, if this is my cosine curve, then I'm going to go down. Now where does it cross the x-axis, right? So remember, that is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So this is at negative pi over 2. So does it go to a negative root 3 over 2 between 0 and negative pi over 3? No, it doesn't. So there are only 2 solutions. So that's one way you can think about it. Otherwise, you could graph it. This means there is 1/3 of a cycle between 0 and 2 pi. So 1/3 of a cycle is a bit bizarre, but then to try to draw that, sorry, but now we're going from 0 to 6 pi. So if there's 1/3 of a cycle between 0 and 2 pi, that means between 0 and 6 pi, there's a full cycle, right? So there's going to be twice where that happens, and then you would keep going over here, so you're not going to have your negative, so that's it. Or you can say there's 1/3 of a cycle per 2 pi. There is then 3 sets of 2 pi's. That's 3 sets of 1/3 of a cycle. So that is 1 cycle in 6 pi, which means there's 2 solutions. So yeah, that's another way of doing it. Sorry, hope I didn't confuse you. Try a few in the homework, see how you do. And then if you're still having trouble, make sure you ask a teacher. Bye.